numbers are arranged in different ways. There are things such as monomials, binomials, trinomials, polynomials, coefficients, and etc. Furthermore, we will all have to know what you need to know about Bob Nye the Math.
Bob Nye the Math Guy. 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 Bob Nye the Math Guy.
Did you ever stop to think just about more than constants or whole numbers? All numbers come together in different ways. Some have degrees, some have variables, but all these numbers are awesome, right? But now let's get to the point. What are polynomials and monomials? We hear them everywhere in math. Polynomials this, polynomials that, monomials this and that, and this and that, this and that, and this and that, and this and that. Anyways, a monomial is an expression that is a number, a variable, or the product of a number or more than one variable. Examples of monomial include 7, negative 3x, negative 5x squared, or y over 3. Although y over 3 may not seem like a product of something, y over 3 may seem like division, but however division is similar or even synonymous to multiplication, because y over 3 is in division y times y divided by 3, but in multiplication it's also y times 1/3. The prefix mono in the word monomial represents the single.
Him, you are disturbing his show. Please get out.
Moving back, the prefix mono simplifies the fact that in every monomial, the product is always end up in a single entity, or all the variables and the numbers multiplied up to a single number
Or variable.
Moving on to polynomials. Polynomials are the sum or difference of more than one monomial. Most polynomials are grouped in parentheses to show the fact that they are a polynomial and they stay together. There are many types of polynomials, such as binomials, trinomials, and etc. We can categorize these polynomials by looking at the prefix. Bi means 2, tri means 3. So in a binomial, there are 2 monomials, and in a trinomials, there are 3 monomials.
Ooh, interesting.
Tommy, eat the bread.
No, the bread is like x squared, while the glaze is x. You can't eat them. You can't eat them together because they're not like terms.
Actually, that is true, so you should eat them separately.
No, I hate the bread.
Whatever.
Next, I'll be showing you how to do operations on polynomials. A sample problem: 2x plus 3y plus x plus y. Now, by using our knowledge on orders of operations, we know that x and x are like terms, while y and y are like terms. So we can combine x and we can combine y and y. That gives us an answer of 3x plus 4y. Now, this is the simplest answer in its simplest form, because x and y, we know that they can't be combined because they are like terms. Now, moving on to subtraction with the same problem, but changing the operation to a negative sign. This problem is very similar to addition, but there's a negative sign, and we need to use distributive property and multiply the negative sign with every number in the parentheses. And again, x and x like terms, y and y like terms, so we can combine them. And that is our final answer. Now moving on to multiplication. And again, using the same problem, 2x plus 3y multiplied by x plus y. Now for polynomials, there's a very complex way to solve multiplication in polynomials. First, we multiply the first number in the first parentheses with the first number in the second parentheses. This is called FOIL. Then, we multiply the first number in the first parentheses with the second number in the second parentheses. Then, we do the same thing with the second number in the first parentheses. Multiply them with both numbers in the second parentheses. That gives us an answer of 2x squared plus 2xy plus 3xy plus 3y squared. Now, xy, 2xy, and 3xy are like terms because they both contain variables x and y. Therefore, we can simplify this answer into 2x squared plus 5xy plus 3y squared. And this is our final answer since none of the terms are like each other and cannot be combined. For pancakes, join us in...
Consider the following.
If you want to double, triple, or quadruple the amount of pancakes, in case there's like some special guest or you're hungry, you can just use the expression. This expression.
which is a made-up recipe.
And then just do some certain operations. For example, if you want to double the amount of pancakes you consume, you just use this expression and times the whole thing by 2. Like this.
Yeah! Thank you for joining us in...
Consider the following.
However, the most common mistake that people make is that they multiply the powers together, which will give you 6x cubed,
Oh god.
which will give you 6x to the 6th power,
Yay.
y to the 12th power. However, the correct way to do it is to only multiply the constants of the like terms together and add the powers together, which in this case, you will multiply 3x squared and negative 2x cubed together, which will give you 6x to the 5th power, and multiply y to the 4th power and y cubed together, which will give you y to the 7th power. Like this.
Hi, my name is Pim and this is Dr. Sanarok. We're both from the Architectural Infrastructure Center. As architects, we always use polynomials.
So, I would like to explain that this is a case from Mr. Robert Ledley. He wants us to find the maximum area of this rectangular pool. This limited area makes us have to create a perimeter of 56. Pim will explain what is our equation.
Our equation here is the area of this rectangle, which we multiply x and y because you know that the formula of a rectangle is length times width. Now, this is also another equation. We use polynomials in here, which this is finding the perimeter by adding 2x and 2y, which will equal to our perimeter, which is 56.
Then we change the equation into y equals to 28 minus x, and then we substituted in x times y equals to area. And then we use the knowledge of polynomials to get this answer. 28x plus x squared equals to area. And this equation tells us that the maximum area that could occur in this situation is 14 on the y and 14 in the x, which equals to 196 square meters. Thank you.
Everybody wants polynomials, which made are polynomials. In fact, it has some variables and are raised with power or degree. There was a cool polynomial from a funky math town. They were adding them up, they were subtracting them down. It's an ancient math art, and everyone knew their part. With the same variables and identical degrees. Everybody wants polynomials, which made of monomials. It has some variables and are raised with power or degree. There was Funky Ball Nye and Little Polynomial. He said, here comes the boss, let's get it on. So we multiplied and divided, start combining the degrees and subtracting the degrees out. Now let's multiply the constants. Everybody wants polynomials.